Okay, so this is the point on this chapter that we start doing some derivations, okay? But the first one is pretty straightforward, and again, it might look intimidating because we call it a dipole, a new term, and but it's just two particles, and you already know how to treat a single charge. You can find electric field at a point P, so just find due to electric field due to both of them, and do your superposition, meaning add up the vectors in a vector form to find out the net force, not force, field. Okay, and this is gonna happen. I keep saying force instead of field. Just bear with me. So you should see some boxes like these ones on your package, and we're gonna fill these out. It would be great if you try it yourself first, and the textbook also has details. But so what we are trying to do here is we are writing the net electric field, and that E here is the net electric field. Okay, we already said that net electric field is going up, right? So that is E. So then what you see is then in magnitudes, the first box, since E points along the E plus, right? This is going to be E plus and this is going to be E minus. Okay, so that's what we're seeing. I'm going to move on to my next slide. So then we are writing E plus and E minus. What are they? We are using Coulomb's law. So one thing is, again, this is a K, right? So I usually use KQ over R squared. Here we have K, instead of K, because we know that K is 1 over 4 pi epsilon naught. We are using 1 over 4 pi epsilon naught instead of K, okay? The textbook uses that more often. It's just shorter to me when I use it, when I write it, but it's the same thing, so there's no difference. Okay, so what do we put on those boxes? Just follow and be consistent. So for E plus, we have R plus, right? So that means when you find the electric field of plus Q at this point P, for writing this, you have to use this distance, and that makes sense. And for E minus, you have to use this distance, and that makes sense too. Okay. Next is how do we, so this is it. Like, first of all, this equation here, you're done. Like, you wrote down what electric field is. Unfortunately, like, they don't look like anything, and if you don't know those R's and anything, like, you cannot solve it. So we are trying to generalize this, and now we'll look into some limitations and approximations. To be able to do that, we need to make those R's in terms of some other common stuff, okay, common distances. So remember, we had two more distances here, Z and D. We're gonna make use of those to write those R. So take a moment to think about how would you write R plus? R plus is from here to there. So it's not Z because it's shorter than Z. So if you take this, sorry, press the wrong stuff. Okay, put it here. If you look at this part, not here. Okay, so I need to figure out how much this part is, right? Then if I take that part out of Z, I can get R plus. And since this was the center, so this is half of D, this is half of D. So what you see is then on the box we should put Z minus half D, right? And now you're going to square that. Same thing for R minus. You need to write this whole thing from here to all the way down there. So you have up to here, you have Z, this is Z. And what is this much? That is half D. You're going to add them up. So one is plus, the other is minus. Again, you can see them here now. Okay. Next is we are taking the common things out of the parentheses. So we're writing the common factors. Q is common in both ratio, right? Q comes out. So these Q's. You can see that Q. Also, 4 pi epsilon naughts are the same. So we are putting 4 pi epsilon naught as well. Okay. And there's also z squared. Where did that z squared came out? So that's the question. So it's like a puzzle. Okay, I want to make this a little bit more interactive. So that's why I put those boxes in here. So if z squared is out, what else? What you should put in those boxes? So I want you to figure that out. Okay. So you need to think about these parentheses first. So you have z minus 1/2 d, right? Let's just think about this one. And this is squared, right? You see that? And I want to write this in terms of z squared out and 1 minus something. Okay, what is that something? And this is squared still. So when that z squared came out of here, right? But when it was in it, it should be z because this was already squared. So what I'm really taking out from the parentheses is z. So now I'm going to focus on inside the parentheses. How do I take z out here? Let's just take that z out. So what I'm really doing is I'm dividing both terms with z and then multiplying by z. And I already multiply by z, so now I need to do divided by z's. 1/2 d over z, okay? So what I'm getting here, since this is the first time to do this, it may not, like you may think like, why are we doing this? You'll see why soon. I want to write these two separate terms under one equation, okay, one term. Not positive, like we have a minus sign here. I want to combine them, and this is the way to do so. So that becomes 1, and here's my 1, and minus, what is that then? D over 2z. Okay, and that z here will come out of that square as z squared here. Okay, so remember this whole thing was squared. Okay, when you take this out, this square will also apply to that, and it comes out as z squared. So that's what we have here, z squared, and this is what you put in those boxes. So you had a negative 1, and for positive 1, these are going to be all positive, but it's the same value that goes in that box. And here you go, you have it here. You see that, d over 2z. Okay, now as you can see from here to there, instead of having two different terms, we have everything under one term. It doesn't look maybe nice yet, but when you look at some limiting cases and some different cases, that will really help us a lot. And that's what we do in physics. In most of the cases, we make use of some math or algebra or calculus, and then we try to make sense out of them. Okay, so here, what goes in that box? Let's see what changed. So what we have here is, so if I say, to make this easier, 2d over 2z, let me just write it here. D over 2z as, let's just call this something else. Can we call this x for now? Okay, x mean nothing. Okay, it's just, I'm just redefining it. Instead of keep writing d over 2z, I'm just gonna write x. So what I have is then, and I'm just focusing on this parenthesis, I'm gonna write that parenthesis here, 1 minus x squared minus 1 divided by 1 plus x squared, right? And we're saying that, and look at these two, these are the same, so we did not put anything out, so these are still the same. This whole parenthesis here turned into this. Okay, so let's find out what goes in there. So this becomes 1 minus x, right? This is x as I define it, square, parentheses, square. And what goes in there? That's the question. So we are going to think about a couple things, and this is 1 minus x, this is 1 plus x, so they're very similar except those minus and plus sign, right? So if we multiply, so what we need to do, first of all, like you can see that there are two different terms here, and then becomes 1. How do you make that? You need to make the denominators the same, right? You need to multiply this one by 1 plus x squared and this one by 1 minus x squared. Then they will have the same denominator. And it turns out when you do that, 1 plus x squared times 1 minus x squared, that is really the same thing as writing. I'm gonna now do, oops, raising those squares and putting them under 1 square. That's the same thing as, again, now distribute that. What you're gonna see is 1 minus, so you have plus x minus x, they cancel, and then minus x squared. See, that's, we already got the denominator by doing this. So but we need to apply this top and bottom, right? And we just double check that when we do that, the bottom gives us what we need. So what goes in the top? Okay, so you have 1 plus x squared multiplied by 1 minus x squared. Let me do that up here because I don't have much space left. So we have 1 plus x squared, and that is 1 plus 2x plus x squared. Okay, unfoil that. 1 minus x squared, and that is 1 minus 2x plus x squared. And you know that there's a negative right here. We need to be paying attention to that. So the second term will be minus. This becomes positive and this becomes minus. And you're going to add them up, right? The numerators add up. So these two will go away. These two will go away, and you got 4x. So what is 4x? X is d over 2z. And that is going to be, when I put this back in here for x, that gives me 2d over z. And that is what goes in this box here. Okay? I know it's a little messy, but it helps you if you do it yourself. So after watching this, you can pause it anywhere, try it yourself, and you'll see what I'm talking about. Okay? It's not really that hard at all.